Right, hello everyone and welcome. My name's Ben. I'm one of the organizers here at the Nottingham Data Science and AI Meetup. You're all very welcome. Nice to see everyone here. Also exciting because this is actually our first data science topic in a while, so I'm quite excited because since ChatGPT and all that did their thing, it's been a lot of AI focus and it's nice to have a bit of a change. The main thing that we're here for is we're here for people looking analysts, people that want to find out what's going on in the market. We're here for people that have projects, have ideas, people who are really just interested in wanting to find out what's going on in the industry. Basically, there's a list of things that we're here for, and we're really here for all of it. So whatever you're here for, if it's to hire people, if it's because you're interested, it's because you want free pizza, whatever it is, we're here for you. And the main thing is we're just trying to create a bit of buzz, create a bit of tech community, and get things going in this city. Professor Royal Huddle, who's going to be talking about how I should investigate data quality. Please welcome Professor Royal Huddle.
Thank you very much for coming. I'm Roy Ruddle. I'm a professor at the University of Leeds. I'm the Research Technology Director at Leeds' Data Science Institute. And one of the areas where I specialise in is data quality. So I'm really delighted to be able to have the chance to come and talk to sort of fellow analysts, data scientists, practitioners about how I think is the right way to investigate data quality. While I'm going along, if you've got questions, do interrupt me. I'm going to start with a little bit of an introduction to data science workflows. So this will be telling you things that most of you already know. A data quality taxonomy, and then the question of, what do data scientists want? And I'll be interested to hear your thoughts on that. And then for most of the talk, I'm going to tell you about two things that myself and my team have created, which are completely open and completely free. One is a 6-step data quality method, which we first published 2 years ago, and the second edition was published last month. And secondly, so that's a document and associated sort of crib sheets in the Excel spreadsheet form. And then one of the ways you can implement that 6-step method is using Python, and in particular the Viz Data Quality package that I've created. But if you're an R user or you've got other software that you're routinely using, the method can be implemented just as easily with that. And then at the end, I'll recap on some of the benefits of adopting this approach. A little bit about myself. I have a very interdisciplinary background. A long time ago in industry, I actually worked here in Nottingham. These are the sort of application areas in which I've collaborated over the past, 15 years or 20 years or so. I'm an expert in data visualization and data quality, and the work I've done on data quality includes a lot of hands-on work with health data from hospitals and GPs, radio astronomy, supermarkets, petrophysics, and even train doors. In the research I've done in the past, some of it has been commercialized. So the Leeds Virtual Microscope, that's a biopsy there. That is used around the world to diagnose cancer. This was a petrophysics spin-off, but to say the data quality work is completely open, and that's what I'm talking about tonight. So how many of you are analysts or data scientists in some shape or form, or spend some of your time analyzing data? Reticent, yeah, well, even if you're doing like, you're doing it sometimes. So this could be called an idealized data science project, and I've heard a little bit of laughter, which I anticipate that. In an ideal data science project, you spend a little bit of time getting hold of the data you need, and the vast majority of the time that's allocated to the project in the real stuff, the modeling and analysis. But the reality is that it's very different to that. The reality is it's more like this, and it's widely known that the preparatory stages of any data science project usually take more than half of the total project time. And this preparatory part, it's to do with discovering the data, getting it into the right format, cleaning it, and so forth. There is a lot of work going on there. But one of the questions we ought to be asking ourselves is, why does this data preparation take so long? And so what I'm talking about today in terms of this method is something that will help you speed up the data cleaning, data quality element of that. Over the course of my work, I've talked to a lot of data scientists, I've surveyed them, I've interviewed them, and coming out from that, we know that a typical data scientist has really little training in data quality, little formal training in data quality, and that's true also of the degree programs in Leeds where I work. We pay lip service to that and dive into more complicated modeling. So the data scientists, they're cleaning data in a fairly ad hoc manner. It tends to be an undocumented process. There are exceptions to that. But also, most of those data scientists I've talked to, they really want to do more. They regret doing more, and what they want to know is, what should they do? What constitutes good practice when it comes to investigating data quality for a given project? Is there some kind of rule book that they can follow? Is there maybe even a formalized process that they can follow? Some people want something rigid, other people want something a little bit more flexible. And it was because of that that we developed what's now called the 6-step data quality method. It was to provide and document something that we consider to be good practice that's founded on the data scientists and analysts I've talked to who are working in 15, 16 different industry sectors. I'll give you the final slide, by the way, I've got has got some links to the method to make it easier to go and find it. Now, quite a lot of you have worked as analysts, or as data scientists, or at least are doing some data analysis in other aspects of your job. What's gone wrong for you? What sorts of issues have you found with your data?
Maybe formatting and classification.
So formatting, not in the format you expected, or not in the format your software needs?
So for instance, you'd have problems where values aren't within specific ranges, for instance, or maybe you even have an issue whereby you have a text value, but it's not in the language that you want.
Yep, okay. And what other sorts of issues are you coming up? What can go wrong with your data?
Mismatches.
Such as?
So for university examples, the student says they have disabled students allowance, but they don't have disability. Those two things can't be true at the same time.
Right, yeah. So there's incompatibilities in two types of data. Other things? Missing values, yeah.
Time issues, just getting time formats.
So
Ingestion in terms of source system. That's a common.
time formats, and then sometimes the time data is not granular enough for what you need, and so forth. So, too many dimensions, too much data. Too much data is a problem because you have to work out how to cut it down. Which bits do you need, which bits do you don't need for the particular analysis that you're setting out to do. So yeah, there's loads of things there. These are just some of the ones that I like to highlight. Missing data in its many forms, and sometimes missing data is not that important. Other times it's critically important. Coverage, when you suddenly find that you thought your data was complete, but then some of the sensors were not reporting for periods of time. You can get changes in longitudinal data that's going on. One of the key things you need to remember with data is that everything that can be wrong will be wrong at some point with the data when you're working with it, and often that's sooner than you think. So rather than dwelling on the problems, what I want to be doing today is to giving you some pointers towards a solution. And so I'm going to run through what, when, how, and why, So the what and when are to do with the method itself, and the how I'm going to illustrate with the Viz data quality package I've got, which will show you some of the checks that we're making, and the why as we go along will become apparent. If you actually create a taxonomy of all the different data quality terms that are out there, then there are well over 100 of them, and that's something I did in some work published 3 years ago. But part of the problem with that, there's so many, but also while some, like missing values, are easy to understand, many of the terms are rather cryptic. You know, what is a semi-empty tuple? What's an approximate duplicate? This is the language that's used in the field of data quality and is rather impenetrable. And so what we did in coming up with this 6-step method was to condense those 100-odd tasks slightly into a set of 69, but then we put a lot of effort into writing them in plain English. So for each of them, the task is hopefully fairly easy to understand. It gives you some sense of what that data quality issue is about. And then for each of these tasks, we've come up with 1, 2, sometimes 3 or 4 questions to ask about your data or to consider asking about your data. So taking missing values as an example, one really obvious question when you're thinking about a given variable is how many values are missing? And that's the sort of check that most analysts and data scientists would do. But a different type of question is, did you expect the variable to be complete? Many people don't stop and think about that, because a variable that should be complete, even if it's only missing a few values, is a signal of something being incorrect. On the other hand, there are other variables which you know that it is correct that there will be large numbers of missing values. For example, if you're gathering data about certain types of patient, there'll be certain types of measurement that aren't taken. So that's the first bit of the what, but then if you've got these 69 different tasks, that in itself is overwhelming. You know, if I said to you, right, in order to check your data, you've got to do 69 different things, you go, oh, come on, get real. So what we've done is we've divided these up into 6 different steps. So on average, you know, 11 or 12 tasks in each of the steps. And these aren't mandatory ones. You know, this is guidance to you about the tasks you should be performing. And the steps go from bottom left up to the top right. And for each of them, I've highlighted an example of the tasks that are there. So the very first thing that you want to be doing is looking at your data, looking at the documentation if it exists, and just asking yourself, is anything obviously wrong? And one of the ways of doing that is just to print out a few example values. You'd be surprised what you might learn. The next step is watching out for special values. So special values are where data has been curated, but let's say each missing value is now not blank, but it's being given a specialist value, like maybe a very large integer. Or if a value is known to be invalid, it's outside of the range, rather than leaving the incorrect outer range value there, it will be given a special value in a company's QA process on their data. Only when you've actually identified those special values are you in a position to decide what to do to them, so maybe turn them into nulls themselves, and ask the question, is any data missing? So where people tend to dive in straight away and say, right, what data is missing? No, that's only appearing in the third of the steps. Once you're satisfied with what you've got there, it's good enough to continue, then set about checking each individual variable. So here, if you think about a data table or the individual tables in a database, this is about checking an individual column. And there'll be certain checks you want to perform on those. And then you want to go on to a step, the 5th step, where you're checking combinations of variables, the values in combinations of variables. So like the discrepancy that the lady towards the back was talking about in one of her examples of 2 mutually incompatible values for to do with students. So this is where your business rules come in, that you might be coding to use to check the data, but also the assumptions that you've got. And if you're making assumptions about your data, always check whether or not those assumptions are correct. As you go through the steps, you'll be cleaning the data as you go, and then at the end, profile that clean data, because that's the data that you're now finally able to start using in your modeling and in the analysis. But it's a little bit like a game of snakes and ladders, because at any point along the way, you might discover something that sends you all the way back to the beginning. You might discover that there's something profoundly wrong with some of the data at this stage, which sends you all the way back to here to obtain the data or to revise the aims of the analysis that you're doing. And so what we've done in choosing the tasks here is to think about a logical order for finding things out, so that the most catastrophic things are likely to be found out earlier. So that's the when. We've done the what, we've done the when. In terms of the how, so I'm going to illustrate this with the Viz Data Quality package that we wrote, so you could do it with other software as well. That package has a lot of example notebooks to help you get started with it. Under the bonnet, it's built on top of pandas and matplotlib, and it's been done in such a way to try to allow keyword arguments to be propagated through down into those lower level libraries to make your life easy. And the package also provides some help to help you sort of document data quality issues while you're going through the checks, and then auto-generate or automatically output a report. The data set I'm using this is the kind of data that anybody can understand. It's to do with parking fines. This is open data. There's 10 years of data on Data Mill North, but what I'm using is just the data from one particular quarter, January to March 2019, and a version of this analysis is also one of the notebooks that's in the Viz Data Quality package. So I say, is anything obviously wrong? One of the best starting tasks that you can do is just to print out the first record, the last record. Often the last record had more problems than the first one. So this is the last record from this data file. What do you notice just from looking at those values? Yeah. There's a last pay date, but nothing's been paid. Yeah, that's one thing. What's unnamed? We don't know, but you've noticed something that, hang on, I'm going to have to look at that, both of these things. What else? Yeah, so £50 fine, nothing paid, balance of zero. Something very odd going on there, yes. And other things? Issue date and last pay date. It's possible.
Again, the fine doesn't have a format to stipulate that it's actually pounds or pence.
Yeah, so to be fair, the website that this comes from on Data Mill North, which is an open data repository, gives a little bit of documentation about the data set, saying that the fines are either 50 or 70 pounds. It's from Leeds in Britain and so forth. So fair comment, but in this case. That documentation also says that there's information about dates and times. Is there? So we've got date information here. Also, this hasn't been converted into a date format, so this is literally the text it is. So by printing out these example values, we're able to see that these dates are in day first format, one of the many formats you can have, because you can have year first, you can have month first, and so forth. So yeah, you've done well. What's this unnamed variable. You haven't seen the documentation, but actually, so PCN is the identifier for a parking fine, parking charge, notice, and contravention. Neither of those are actually documented on the web page, but the other things are. The format of the date, there is no time information. So if you read the web page, you might think you can do time of day analysis. When you look at the data, you suddenly find out, no, we can't do that at all. If that's what you want to do, you'll have to find some other data. You picked up about these logic errors that are there. So there's a huge amount you can learn just by spending the time printing those things out. In terms of special values, I say in this particular data set, there aren't any that are coded as large integers or very old dates or so forth with special meanings. But one of the worst type of sort of special values is where the value 0 is used as a default by a system. And in these visualizations, the y-axis is sized to be the same as the number of rows in the data set. So we can see that almost every single one of the records has a balance of 0, which seems very odd. And you picked up the issue here. I mean, if you've got 2,000 with 0 paid and 6,500 with balance of 0, clearly that's incompatible. But rather than looking into those straight away, we'll file those away to step 5. Is any data missing? So you could have found this out at the very beginning. But what you see if you literally just look at the blank values in this data frame is that all of the variables are complete apart from the unnamed one that's missing every single value. What do you think's happened? What's caused that?
It's not a number, it's not a null. Maybe some transformation.
It's literally blank. Yeah. Every single row in the CSV, including the heading, the first row, ends with a comma. And so software like Pandas will say, oh, well, there must be a column after that. So it's a very simple problem to fix. And in fact, you can fix it at this point by just saying, okay, well, we get rid of that final column and move on. So we got on to step 4. Checking each variable. I'm just showing you 3 tasks here, but there are quite a few more in the method. One thing that's very useful to do for all of the variables in your data set is find out how many unique values there are and relate that to the number of records. So again, the x-axis here, the range here corresponds to the number of rows in the data set. So we can see that PCN, 3,900 PCNs, but there are actually 7,000 rows there. What do you think's happening? Duplication, there could be, and that's something you would check. Actually, no. Yes. So in this particular data set, you got it right. You can pay your parking fine in increments, and this is the data of all fines issued and all payments made, all rolled into a single file, and it says so on the documentation for January to March 2019. So what that's saying to us, and then if we then do an investigation of what's going on here, we see that for 1,000 of the PCNs, they appear once. Most commonly, nearly 2,000 PCNs are appearing twice, and some can be appearing as many as 5 times. That in itself is not necessarily, is not wrong, but it's likely to be different to what you assumed the data would be. So thinking about that, if you want to calculate how much have people paid in total for fines, Yeah, issued is actually the date that's issued. But the PCN is the unique identifier for a given fine.
But if they're split, if they're paid in increments, the issue date would be the same.
Yes, yes, yeah, and it is the same. So, and the location, the car park is the same. What you did wrong, the contravention will be the same, but the last pay date and the balance and the total paid should logically be changing. So if you want to calculate what was paid in total, how would you do it, knowing what you know now?
I have to look at the data and see what it looks like in practice.
Proved by the unique identifier over time. Could be another 3 months just look over further over.
Yeah, so sure, it's not easy to do this in an abstract way, but if you just added up all the numbers in the total paid column, so you're getting multiple entries for most of the PCNs, then you'd end up with £190,000 were paid. But if you actually took the maximum for each, so the last entry for each of the PCNs, you'd get what we would hope is the true number, which is 106,000. But again, it's an illustration of you need to understand this about your data, otherwise you end up calculating completely the wrong answers in your analysis.
If you were calculating like that, it would mean that if someone failed to pay their parking ticket, then you would have 2 sequential parking tickets issued, which would make the total paid incorrect.
No, the PCN remains the same. And in fact, this doesn't record penalties.
So there's constraints on the PCN itself.
Yeah, a PCN is a unique identifier for that particular parking ticket. When you're looking at dates, dates are quite a complex data structure. And so as well as looking at the distribution of the raw data, it's a good idea to look at it at different levels of detail. And we make this easy with a single convenience function. So we can look and see what's the issued year for the various records that are in this data file. So most come from 2019, the January to March 2019, a few as old as 2017. But whoa, we've got some that are also from 2009. That's very, very strange. We can see that the majority of them are issued in January to March in terms of time of month of the year. That's kind of making sense. We're seeing variations across the day of the week. These are the kinds of way you can look at the data. And value lengths is where you're looking at how many characters are in each variable. So, for example, dates, if it's a dot here, it means every single value has exactly the same number of characters. So with dates, you would expect that to be true. With PCNs, that's probably quite nice that it's true. It means it's always a, whatever it is, an 8 character identifier. But when you get large ranges of value lengths for a given variable, that can ring alarm bells. It's something to check out because it might be correct as it's text, or it might be wrong. And if you've, in this case, if you look at it, and again using some convenience functions, you see that some of the locations have loads and loads of trailing spaces in there. Having found that, that's another really trivial thing to clean up while you're going. So step 5, I've only got a few more slides. We now go on to the step of checking combinations of variables. You'd picked up in the very first step the inconsistency between fine, total paid, and balance. So what would be a check that you would want to do on this data to investigate that? Yeah, and we can actually even go fine minus total paid minus balance from the same logic ought to be 0. That's our assumption. And so if we do that, we find that that's not the case. So only 800 records end up with 0. The most common remainder is actually 25. Now the fines that you can get are £50 and £70. So what do you think's causing the 25 here? Yeah, pay within 14 days, you get a discount, and so this is telling you all sorts of things. These particular columns are a real nightmare in this data, but you're now aware of what's going on, and you'll then be able to investigate it further to decide what analysis or what adjustments you need to make in your analysis software in order to do the analysis that you intended. Once you've done all that, you then profile the clean data. I'm not going to run through that here. In terms of generating a, yes?
Sorry, just a question from the last slide. If this rule was applied to those that were paid in parts, the total fine or the balance, would it still be 0? Because for those that are paying in parts, for example, someone has £500 to pay, and let's say they pay £100.
You would expect it to be 0, because if you have a fine of 50 and you pay £10, we'd expect the balance to be 40. If you had a fine of 50 and we paid £20, we'd expect the fine to be 30, the balance to be 30. So yes, that's the thought process. I've used this data set on many students, and that's what they expect. And then they find actually, no, the data set the logic is a lot more complicated. This is doing a calculation on each row separately. So it's saying in a row, does fine minus total paid equal balance? And the answer is not often, for various reasons. But you need to understand the reason if you're going to analyze the data and do some correct modeling. So the report we can generate in 3 formats. You do have to do a fair bit of work. It's not like chuck it into some large language model and let it hallucinate and give you a report about your data quality. This is under your control, but it's taking some of the heavy lifting out of it. And so coming back to the why. We think a guaranteed win with this method is we're documenting explicitly what we suggest data scientists and analysts do. So we're telling them what to do. They haven't got to ferret around that. So they ought to be able to do more checks in less time, or more checks in the same time that they're currently doing. By getting the order of those checks appropriate, we can hopefully avoid some of the rework that you do, so that you discover the most catastrophic things early on, or with this issue with fine, total, paid and balance, you discover it before you go into your modeling rather than when you're making the final customer presentation. Everybody makes assumptions about data. You were making assumptions about data, albeit based only on what I was showing you. And now you realize that some of those assumptions were not quite right. Very often you'll find the data's correct, but it's just your assumptions about the data are incorrect. And as we go along, we can improve the data. So just to wrap up, what I've talked about, the 6-step method, it's openly available. The Python package also is. There's enough information here that you could just pick it up, read it, and begin to apply it yourself, and some people have done that. With Jonathan's help, we're creating a set of YouTube videos that will bring some of this to life to help you learn about that. I'm rolling out some examples with Data Mill North, and I'm also running a series of one-day courses where I will be working you very hard on tabular, longitudinal and spatial data. And so I'll conclude here with the URLs, and these are the QR codes for the various URLs of the method, the package, a copy of these slides, and if you're interested, the courses that are running in May and June. So thank you. And I'll take questions.
Any more questions? No? Okay, thank you very much.
People want pizza.
Yes, we have pizza coming. Oh wait, we actually have a
Oh yeah,
question.
yeah.
Pretty sure you're going to hate the question.
All questions are good.
So, any chance you're thinking of rolling out a skills MD file, right, for one of the language models to actually use the existing method and sort of teach an agent that particular skill? And then, I mean, in my particular case, I have a bunch of data sets, structured, you name it. There's a whole shit show, probably like a few gigabytes. I don't even know what's going on there. So for me, it would be ideal if I can have a skills MD file that I can hook up to my existing sort of local LLM that I can run locally, so I don't have to run through so many credits. And then maybe use your methodology as the core of that. I think that as a service would be great, because I have this huge pain point of all of this unstructured data sitting on my laptop, and I need to make some sense of it. But I don't have the time to do so.
And you want a magic button to press to give the answer. Yeah. So yeah. No. I mean, I think that's a great question, and I like hearing these things. And I would say that would be perhaps an ambition. But I think there are other steps that are better to take first and which are safer to take first, because as soon as you rely on AI in any shape or form, you need to be asking yourself, how am I going to validate or develop confidence in the extent to which that model is working correctly? And so one of the ways to make those initial steps, let's say across the first, I'm not sure about working with unstructured data. I mean, I'm generally dealing with data tables and relational databases and so forth. But what I would suggest is take the tasks in the first 3 steps, and actually you could pretty well write a set of code that would, with only a little bit of extra logic, would probably work on a lot of different data sets. And that will give you some initial checks of what's coming out. And then, even in terms of when you get into the step 4, if you're dealing with numerical data, then you want to at least be looking at distributions. If you've got, if your data is documented, so there's a good data dictionary, and especially if it's machine readable, you actually load that data dictionary in as a data set and use that to cross-check against all the values in each of the columns. And in doing so, you're actually doing a QA on the documentation, because often there will be mistakes there. So rather than leaping say, well, let's have an AI model to do the job for us, I'd say start by learning about your data, but tackle the first 3 steps, because those are, you can come up with a fairly generic approach. Whereas when you get into step 5, you're now having to think about a specific data set of what relationships are in there, and that will be different for each data set. But yeah, maybe, you know, in a few years' time. But any more questions? Yeah, and one there as well. Go on, fire away.
Yeah, so you've got a data quality assessment method. Do you think one for the corrections, what to do once you find all the issues, is feasible as well? A methodology for that? Or is it too complicated?
It's not just data specific, it's analysis specific. So you can have data that is perfectly correct, but just not appropriate for your analysis. So we said like this car parking data, there's date data, but there's no time data, despite the documentation. So let's assume that the issued dates are correct, but if the purpose of your analysis is to look at patterns over a 24-hour period, you need different data. And by the same argument, sometimes, many times, no data sets are perfect, but often you will find that, let's say, it's good enough to do 2/3 of the analysis I wanted to do, but it's not. But we now realise it's not good enough to do the other third. So it is very dependent on the particular project. There was a question there, yeah, in the red jumper, and then.
You get to the end, and you've figured out what the issues are. What would you look to do from that point onwards? Like, how would you approach, I suppose, fixing those issues that you've got?
So some issues you can fix as you go along. Other issues is not so much fixing them, but you, for example, with the fact that the PCNs typically appear, on average twice. That's about changing assumption, and so you're not then. You might not be modifying the data. You might be modifying your analysis software.
Just having that awareness to then.
So that you're making informed decisions, and you can stand up in confidence. And when you make the presentation, well, to your boss and your team, they have confidence in what you're doing. When you're making a presentation to the client, and they say, "Have you checked that?" and you say, "Yes, we have actually. It's this." The last thing on earth you want is to be standing in front of the client, making the presentation. They spot something which is looking odd, and suddenly it derails all the work that you've done. And it's happened to us all. You had another question?
Just a curiosity question, I guess. For the data sets, how often would you first have a look at Jupyter variables manually or things like data wrangler? Or would you just jump into using the package distributions and general data?
I think the key thing would be to look at the types of tasks that we recommend. So in visualization, I've used a number of commercial packages as well as doing research to generate new ones. So Tableau I know very well. But what I've not used are things like Trifactor and so forth, because that's not been necessary in my work. But think about what's the workflow you have at the moment. If the software is sufficient, the 6-step method can help you make use of that software in your time more effectively. Whereas for others, they go, oh, actually, well, I need some software and I want it to be free and open, hence Python goes. And maybe someone else will come along and write an R version. But I'm afraid I'm not an R person, so that won't be me.
The example in this presentation, and thank you for an interesting presentation and for the paper as well. But the example is a static data set, but apparently it finds data, so it's dynamic and converted probably in streaming. Which parts of your data quality framework can be used for monitoring of data quality in the pipeline?
So I would say that there are some groups within my own university on the sort of admin side and student record side who are now trying to do that. The first thing is to take a static cut of your data to understand your data yourself, because that's often not done. But then once you've done that, work out what should be the automated checks that you want to be running each month or however often a new tranche of data is fed through. And then what are the alerts? Having understood, okay, yes, I now see what the distributions are, and yes, we kind of think those are okay. What alert thresholds do you want to set so that you can then write those business rules to generate the alerts, so that if you don't get alerts through, you have confidence that the data is, broadly speaking, similar to what you had before. But you know that if you wait long enough, something will come through that's just complete rubbish, and those alerts will catch it for you. So it's about there are people that have been on my courses who are now trying to take the method and to productionize it in that way. But you've got to be sensible about the amount of work that you're doing.
Any other questions? Oh, there we go.
Sorry, on your first slide, you you mentioned there was a cancer detection under this.
Yeah.
Was that using computer vision?
No. So this is human. So this is a biopsy. If you scan, this is going off topic from today, but if you have a biopsy and it's put of tissue because a tumor is suspected, and the pathologist will take little thin slices of that and put it onto a little glass microscope slide that's about 1 inch by 3 inches. And then today, instead of looking at that through a conventional light microscope at up to 400x magnification, the pathologist will make a diagnosis looking at a digitized version of the slide. To show the same detail down to the nuclei, this biopsy here is about 200,000 by 100,000 pixels. It's 10 gigapixels. Oh no, that's more than 10 gigapixels. It has a number of pixels in it as a Landsat 7 satellite image of the Amazon rainforest. And that's one bit of tissue there to show the same sort of detail. But what we did here is we wrote game-changing visualization software, which allowed the pathologist still to be making diagnoses of digital images. This is a 54 megapixel display, so it's working on massive scale, but also on the desktops. And then now you have the digital pathology images. You can then bring a number of computer-assisted diagnosis methods to bear, some of which are fully validated for use in these fields. You no longer, so at St. James's in Leeds, they don't store the glass anymore. They're producing 200,000 glass slides, or they were producing 200,000 glass slides a year. And now with cloud storage, you can now store them digitally such that they don't get lost, they don't get broken. It's easier to look back at previous slides on the patients now that people are often surviving a long time with cancers. But this work was all human diagnosis, and the IP in here is sold by Roche around the world in their digital pathology software.
What's the biggest data set you ever worked with, and what was the biggest challenge you learned from it?
So one of the biggest ones, I was working with some anonymized GP data. I was helping some of our bioinformatics, genomics researchers. So I think there were like 40 million records in that data set, in some of the tables anyway. The thing that most took me by surprise, and I kicked myself that it took me 3 or 4 days to actually work out what was going on, was that I found that the data, as it had been sent by the mainstream health records, health systems company, some of the records were on 2 lines. So you'd have, let's say, most of the rows had 15 variables in it, and a few would have 13, and then there'd be 2 on the next one, which of course really mucks up the data type of those first 2 columns as well. So yeah, that was the worst one. Like I say, I didn't expect that, but.
Another.
Actually, I was interested in the workshop thing that you shared. Can you share a bit more? What does it cover, and is it a free workshop?
Yeah, so these courses I'm running, it's a 1-day course where I work people. I've given it a couple of times already in Leeds. I work people really hard, so I like people to feel somewhat exhausted at the end, but also enlightened. And it's a small amount of me talking and introducing things, but the centerpiece are 3 challenges of 3 devious open data sets that I've managed to find. One is a tabular data, one is spatial data, and one is longitudinal data. And I get, it typically got about 20 people in each of the workshops. I get people to work in groups, to team up on the day, using whatever software they want to bring with them, to work together to do a QA on each of these data sets, and then we recap. We start by saying, so what did people do, and then I've got some exemplar solutions that I've got on top of that, because I know the data better and I've spent more time on it than the hour of working together. The adverts on those are live. Yes, you're going to have to break for pizza, but I'm happy to keep.
We're still waiting for pizza.
All right, okay, yeah, fire away. Yeah, the two, go on.
But there were some identifiers that were in the data. When I discussed with the person that gave me data at the time, I asked whether it was, although identifiers were there, some of the identifiers are also missing. So I just asked if it was okay to like drop the whole column and work with the rest, since we're not actually supposed to identify them anyways. So I figured that's something where I've decided that missing data is okay because we're not supposed to use it. But is there any other situation, let's say for example, you mentioned analysis-specific situations where you have to identify, for example, the time thing. If you want a time analysis, but there's no time, then you can't do it. In a situation where, let's say, you don't want to do time analysis, let's say month by month, right? But you realize that some data is missing.
Yeah. So let me. I'll preempt where I think you're going, and then tell me if it's not quite right. So there's a couple of things there. One is, I deal a lot with supermarket data, with health records data from NHS hospitals, from GP practices, and so forth. All of the data, when it gets sent to me, has been what we call pseudonymized. So that is, there is an identifier for each patient in there, which has gone through multi-layer encryption, so it can't be worked backwards. But that identifier is absolutely crucial in the longitudinal analysis and that I do and a lot of my colleagues do, because that allows us to link all the records for a given patient. Because when you're looking at health or supermarket transactions, you're looking at how does this person's shopping patterns change over time? We don't know who they are because it's an anonymized identifier, but we do know that person X went into Sainsbury's on this date and bought that, this date bought that, this date bought that, or went into hospital for this, for this, for this, for this. So those anonymized identifiers are they're essential for some of the analysis. Now, you talked about, I think, finding an identifier which shouldn't be there, which might allow somebody to be identified. That's the sort of thing I would pick up when looking at the relevant columns in this step 4. You'd be looking, say, at what are the unique values I've got here, and you'd notice something which was, this actually appears to be an identifier that can be used, not an encrypted identifier. At which point, it sounds like you did, you then go back to the data provider and say, look, there's a problem. And they would then, if it's health data, they would then have to instigate a process to deal with that and to delete the data and so forth. What we did find when we were doing this type of thing, and actually came out in the value lengths, the encrypted identifiers, so this was somebody I know I was helping with a lot of cardiovascular research over a 10-year time period. And the identifiers in the first 2 years had 8 characters, and then suddenly the identifiers switched to being 16 characters. What had happened was that the NHS had changed their encryption algorithm from 8 to 16. Great, you think, but you can't link the 8-character ones to the 16-character ones, so actually they hadn't, they should have applied the 16 character encryption to all of the data. As it was, for most of the analysis, those researchers had to throw away 2 out of the 10 years because they couldn't track those patients forward. So all sorts of things can happen with stuff like identifiers.
So I guess the answer would be, instead of getting rid of it, go back to the data provider to see that I'm not.
Well, so, yeah, sometimes. It depends on what you need to do. If your analysis was only analyzing each record separately, not trying to link it across people, which there might be some questions that you'd answer that, then you could drop the identifier column because it's genuinely not needed. But I suspect that would be a rarity. There's one more question, and you'll get the drift of some nice smells coming forward. Far away.
Which software do you usually use for data analysis?
So my research is about developing new visualization techniques, new data analysis workflows, new data quality workflows. But in some of that work, we end up basically writing our own software because there's, and sometimes trying to benchmark it against, say, a best of breed. So in visualization, for general visualization, I'd use Tableau because I know that very well. But then we're doing something very specific, and we're aiming to be vastly superior to Tableau for our particular use cases, whereas Tableau is a general purpose piece of software, which is very excellent for that. So most of the stuff I use now is based around Python.
The last one. How do you, how do you understand the data? Do you speak to your clients every time? Like if it gets stuck?
If you can, yes. Or you're speaking to domain experts. So on health projects, I'm usually working alongside clinicians and epidemiologists and so forth.
Okay.
And it's, you know, it's not easy to understand data.
It's because the clients won't be available every time, you know, like you just have to do your own discovery. Is it allowed in the case?
In my experience, and this also comes from talking to people working inside some quite well-known organizations where the data science teams are separate from the internal client. And one of the things that's most frustrating for them are when they have to be going through endless iterations because they're not allowed to even look or touch the data themselves, even though they work in the same company. Yeah. So what you're trying to do, you know, everybody wants to work efficiently. If your client is paying you for the work that you're doing, it's really in their interest, but you may have to work quite hard to get them to open up, to overcome things. But it does work. I've had some very fruitful relationships with NHS Digital, with Sainsbury's, with Leeds City Council, and they're learning stuff from what we're finding out for them, and it's, you know, it's a very symbiotic relationship.
Okay, thank you very much again.
Yeah.
So there we have it. We're just about at the point of having the pizzas. So this is my monthly appeal for speaker sign up. Anybody has, excuse me, anyone has anything that they want to speak about, anything, it could be a research project, it could be something you're working on, something that you think's interesting, come speak to me, talk to Pog over there, or Misha, or, Richard, or Misha, or Georgie. Yeah, so just come talk to one of the organizers. Brian's another one you could talk to. We'll get you signed up. We really are open to any sort of AI or data science topics. So some of the stuff we have is quite advanced. Some of the stuff we have is quite hands-on. We actually have a real opportunity in this new place to do a hands-on workshop. So I'm hoping we'll be able to do that soon as well. So yeah, so do come let us know. Also, we have a Discord server that if you want to join in the conversation, Richard runs that. I'll put a QR code onto it at the end of this. But do join the Discord server and go in and ask questions and chat if you want. We also have the LinkedIn group. You can leave comments on the meetup, although I don't know if there's much going on there. Next meeting is going to be the first Thursday of